Blockchain and cryptocurrency. Blockchain and cryptocurrency represent a transformative evolution in the way value is recorded, transferred, and managed in our increasingly digital world. Born out of the desire for decentralization and trustless systems, blockchain technology establishes a distributed ledger where transactions are recorded in a verifiable, immutable manner. In its simplest form, a blockchain is a chain of blocks, each block containing a bundle of transactions, a timestamp, and a cryptographic hash of the previous block that is maintained by a decentralized network of nodes. This design ensures that no single entity controls the data and that every participant in the network can verify the authenticity of each transaction without relying on a central authority. At the heart of blockchain technology lies cryptography, which secures data and establishes trust among unknown parties. Every transaction on a blockchain is linked using cryptographic algorithms such as SHA-256, ensuring that even the slightest alteration in a previously confirmed block would require an enormous amount of computational power to modify all subsequent blocks. Digital signatures and public/private key pairs further enhance the system by enabling users to sign transactions in a way that confirms their identity while maintaining privacy. This cryptographic foundation creates an environment where trust emerges not from the goodwill of a central authority but from mathematical certainty and distributed consensus. The decentralized nature of blockchain means that instead of a central server verifying and recording transactions, numerous nodes across the globe work simultaneously to validate and update the ledger. Each node holds a complete copy of the blockchain and works collaboratively through consensus mechanisms like proof of work, POW, or proof of stake, POS, to agree on the state of a ledger. In POW systems, such as Bitcoin, miners compete to solve complex mathematical puzzles, and the first to solve the puzzle earns the right to add the next block and receive newly minted coins along with transaction fees. This competitive process ensures that altering any part of the blockchain becomes computationally unfeasible, as an attacker would need to control more than half of the network's power to modify the ledger, a task that is practically impossible for large, well-established networks. The inception of Bitcoin marked the first practical application of blockchain technology as a decentralized digital currency. Bitcoin challenged traditional financial paradigms by eliminating the need for intermediaries like banks and payment processors, instead allowing peer-to-peer transactions that are recorded on an open ledger. The fixed supply of Bitcoin, capped at 21 million coins, introduced a concept of scarcity in the digital realm, while its pseudonymous nature provided a degree of privacy and autonomy that resonated with those seeking an alternative to government-controlled fiat currencies. Bitcoin's success not only proved the viability of decentralized digital currencies, but also paved the way for a proliferation of alternative coins that have since sought to address various limitations or to introduce new functionalities beyond simple value transfer. Following Bitcoin, numerous alternative cryptocurrencies emerged to expand the potential of blockchain technology. Ethereum, for example, introduced the concept of smart contracts, self-executing programs that run on the blockchain and automatically enforce the terms of an agreement when specified conditions are met. This innovation has given rise to entire ecosystems of decentralized applications, dApps, that operate without intermediaries, enabling everything from decentralized finance, DeFi, to secure voting protocols. Smart contracts are written in programming languages like Solidity and allow complex transactions and applications to be integrated into a blockchain. Their ability to execute and verify contractual conditions autonomously has sparked a surge of innovation in areas such as supply chain management, healthcare, and legal services, marking a significant expansion of blockchain's utility beyond simple currency transactions. The core features of immutability, transparency, and decentralization that define blockchain have contributed to its adoption across various industries outside of finance. In supply chain management, for instance, blockchain can provide an immutable record of a product's journey from its origin to the consumer. This level of traceability not only enhances food safety and quality assurance but also helps in reducing fraud and verifying the authenticity of goods. Similarly, in healthcare, blockchain offers a secure and efficient way to manage patient records, ensuring that sensitive data is only accessible to authorized parties while maintaining an auditable trail of access and modifications. The potential applications are vast, with projects underway that aim to integrate blockchain with emerging technologies like the Internet of Things, IoT, to create smart, interconnected systems that operate with minimal human intervention. The evolution of consensus mechanisms within blockchain ecosystems has been a critical area of innovation. While POW has proven effective for early applications, its energy-intensive nature has spurred the development of alternative approaches such as POS and delegated proof of stake, DPoS. In POS systems, Validators are chosen to create new blocks based on the amount of cryptocurrency they hold and are willing to stake as collateral. This method significantly reduces energy consumption and can increase transaction throughput, making it more scalable for applications that require a high volume of transactions. Hybrid consensus models, which combine elements of both PoW and PoS or integrate additional layers such as Byzantine fault tolerance, BFT, are being explored to balance security, decentralization, and efficiency, reflecting the dynamic nature of blockchain innovation. Cryptocurrencies extend the capabilities of blockchain into the realm of digital assets and new economic models. Beyond serving as a medium for everyday transactions, cryptocurrencies have become vehicles for speculative investment, digital identity verification, and decentralized governance. The rise of decentralized finance has seen the development of platforms that offer services traditionally provided by banks, including lending, borrowing, and trading, operating without centralized intermediaries. These decentralized platforms rely on smart contracts to manage collateral, compute interest rates, and execute trades securely without human oversight. This democratization of financial services is seen by proponents as a way to increase financial inclusion, enabling people around the globe to participate in a digital economy without the barriers imposed by conventional banking systems. The phenomenon of tokenization has further expanded the role of blockchain by enabling the representation of tangible and intangible assets as digital tokens on a blockchain. Companies have begun tokenizing real estate, art, intellectual property, and other assets, thereby unlocking liquidity and enabling fractional ownership. This process not only allows for innovative investment opportunities, but also provides transparency and fractionalization that have the potential to revolutionize traditional markets. By aligning ownership rights with blockchain-based tokens, these systems create overlapping layers of value and new mechanisms for managing and trading ownership in a secure, transparent manner. Despite its promising potential, the blockchain and cryptocurrency space is not without its challenges. Scalability has long been a concern, as many early blockchains struggle to process transactions with the speed and cost efficiency required for mass adoption. Efforts to scale blockchain networks have led to the development of off-chain solutions such as sidechains and Layer 2 protocols like the Lightning Network. These innovations allow many transactions to be processed outside the main blockchain while still leveraging its security and finality when needed. However, balancing scalability with the core attributes of decentralization and security remains a highly technical challenge that continues to drive research and development efforts in the field. Energy consumption, particularly in PoW systems, is another significant challenge facing blockchain technology. The electricity required to power vast networks of mining hardware has sparked environmental concerns and has led to a broader discussion on the sustainability of cryptographic consensus mechanisms. In response, many projects are transitioning to less energy-intensive consensus models or exploring ways to integrate renewable energy sources into their operations. The debate over energy consumption also touches upon the broader societal implications of blockchain technology, as it forces policymakers and technologists to consider how to harness the benefits of decentralization while minimizing ecological impact. Regulatory perspectives on blockchain and cryptocurrency vary widely from one jurisdiction to another. Governments around the world face the challenge of balancing the need to protect consumers and combat fraud with the desire to foster innovation in the rapidly evolving digital economy. Some countries have embraced the technology by establishing clear regulatory frameworks and even exploring state-backed digital currencies, while others have taken a more cautious or even hostile stance. Regulatory clarity is essential for mainstream adoption, as it creates an environment in which businesses and investors can operate with greater certainty. As legal frameworks continue to evolve, the interplay between regulation and innovation will likely shape the future trajectory of blockchain technology and its related financial instruments. Security continues to be a paramount concern within the blockchain and cryptocurrency space. While the underlying cryptographic techniques strongly secure the blockchain itself, peripheral infrastructures, such as cryptocurrency exchanges and digital wallets, are frequently targeted by cybercriminals. High-profile breaches and thefts have underscored the importance of robust security protocols, driving the adoption of multi-signature wallets, cold storage solutions, and hardware wallets designed to protect digital assets from unauthorized access. The ongoing arms race between hackers and security measures reinforces the necessity for constant vigilance and continuous improvement in cybersecurity practices, ensuring that the benefits of trustless systems are not compromised by vulnerabilities at the application level. The decentralized governance models enabled by blockchain technology present another innovative dimension. Decentralized autonomous organizations, DAOs, allow communities of stakeholders to participate directly in decision-making processes through token-based voting mechanisms. In a DAO, proposals for network changes, budget allocations, or project funding are submitted and then voted on by participants, effectively decentralizing power traditionally held by corporate executives or governmental bodies. This model has the potential to transform organizational structures, enabling a more democratic and transparent allocation of resources and responsibilities. Although still in the experimental phase in many cases, DAOs embody the principle that decentralization can extend beyond the technical architecture of a network and into the realm of operational governance. Blockchain's influence is also profoundly felt in emerging areas such as non-fungible tokens, NFTs, which have redefined the concept of digital ownership. NFTs represent unique digital assets that can be bought, sold, or traded on various blockchain networks, providing a framework for digital scarcity and verifiable ownership. This innovation has garnered significant interest in sectors such as digital art, gaming, and collectibles, where the ability to authenticate the provenance of a work of art or a virtual asset adds significant value. The NFT phenomenon is a prime example of how blockchain technology can disrupt traditional markets by offering entirely new ways to monetize creativity and intellectual property. The transformative journey of blockchain and cryptocurrency is ongoing, evolving with each new development and breakthrough. Innovations in cryptographic methods, consensus algorithms, and interoperability protocols continue to push the boundaries of what is possible. For instance, researchers are exploring advanced cryptographic techniques like zero-knowledge proofs, which could allow transactions to be verified without revealing the underlying data, and homomorphic encryption, which would enable computations on encrypted data. These developments promise to further enhance privacy and security while maintaining the transparency and accountability that are hallmarks of blockchain systems. The decentralized ethos of blockchain challenges conventional notions of power and financial sovereignty by enabling peer-to-peer transactions and data sharing free from centralized oversight. This paradigm shift has the potential to reshape industries that have traditionally relied on hierarchical structures and intermediaries. Whether it is through the disintermediation of financial transactions, the transparent tracking of supply chains, or the democratization of organizational decision-making via DAOs, blockchain technology is forging new pathways for economic and social empowerment. By creating systems built on shared trust and collective verification, blockchain offers a vision of a future where control is distributed among many rather than centralized in the hands of a few. As the global community becomes increasingly interconnected, the applications of blockchain and cryptocurrency are poised to integrate even more deeply into everyday life. Payment systems powered by digital currencies are rapidly emerging as alternatives to traditional banking, particularly in parts of the world where access to conventional financial systems is limited. These systems offer a means of financial inclusion that bypasses the geographical and bureaucratic hurdles of legacy institutions, allowing individuals around the world to participate in the global economy. Furthermore, blockchain-based identity solutions promise to offer a secure and verifiable means of establishing digital identities, reducing the risks of fraud and enabling more efficient access to services. The future of blockchain and cryptocurrency is intrinsically tied to the continued convergence of technology, finance, and regulatory innovation. As developers refine protocols for better scalability, lower energy consumption, and enhanced security, projects in this space are likely to become both more robust and more accessible. Governments, institutional investors, and private enterprises are increasingly recognizing the strategic importance of these technologies, leading to an influx of research, investment, and policy deliberations. The interplay between technological advancements and regulatory measures will ultimately determine the pace and direction of blockchain's integration into mainstream systems. In conclusion, blockchain and cryptocurrency stand as remarkable innovations that challenge traditional paradigms of trust, control, and value exchange. Their emergence has sparked a global revolution in finance, technology, and governance, offering a vision where transactions are transparent, secure, and decentralized. While challenges remain, ranging from scalability and energy consumption to regulatory uncertainty and security, the continuous evolution of these technologies suggests a future where blockchain underpins an increasingly digital, inclusive, and interconnected economy. Each new breakthrough, from smart contracts and DAOs to advanced cryptographic techniques, brings us closer to a world where decentralization is not just a technological statement but a fundamental pillar of modern society. The journey is far from complete, and as innovation continues to drive the ecosystem forward, blockchain and cryptocurrency will likely prove to be enduring catalysts for change in our digital era.